Hierarchical clustering. Let's start this. Okay, you can see my screen. Hierarchical structuring is an unsupervised learning algorithm used to group similar objects. Just like k-means, we make clusters, right? Same happens here. Similar objects into cluster based on their distance or similarity. So based on what? Basically distance, but there is many types of distance. Like distance could be, suppose there is two clusters and there is two data points here. Now you have to take the distance from where? Like if you want to take the distance of this one to join these two clusters to make a complete cluster. So you will see the data points within it. Is it the minimum distance between 2 points like this, or you have to take the maximum distance? That is still questionable. Which one we should take? So we'll decide it. So distance and similarity. Unlike k-means clustering, which requires the number of clusters to be defined in advance. So here you don't have to define the clusters in advance. Like in k-means, you remember that n clusters we used to define like 3, 2, 4, something like this. Here you don't have to do this. Okay, hierarchical clustering builds a hierarchy of cluster without needing to predefine the number. Yes. So types of hierarchical clustering is there are two main types. First, you can say agglomerative clustering, like bottom up of approach. Okay, so there is two type of clustering, like whether you go bottom to top, for example, like this, you make clusters. So this is called going from bottom to top. And then we have divisive, means top down. Top down look like this. You start with one and then divide two clusters and further you divide the cluster. This is called top to down approach. This is called divisive. This is called agglomerative. Agglomerative clustering versus divisive clustering. Let's see the example and picture of both. Okay, it is looking almost the same. Okay, so it is almost looking the same. But the difference is of movement. If it is moving from bottom to top, it is agglomerative, but if it is moving from top to bottom, it is divisive, right? Okay, so agglomerative in here, what happens? Uh, Start with each data point at its own cluster. Yeah, so basically two data points are there, so they will be clustered together. First, like, and suppose if you have another two data set, they will be clustered together. And at each step, the two closest clusters are merged. Yes, like this. So it will keep on growing like this. The process continues until all data points belong to a single cluster or a predefined number of clusters is reached. So it will keep on clustering all the nearest point. Okay, and how to calculate whether they are near, whether they are near or far away, that we will see in just few minutes. Okay, so this is called clustering. Okay, now how the DVC work? So start with all data points in a single cluster. So you can take a single cluster which having a lot of data. So it will start like this, and at each step the cluster split into smaller parts. Now here there is splitting, furthermore splitting, like this. The process continues until each data point is its own cluster or the desired number of cluster is reached. Okay, so calculate the distance. So how to steps in agglomerative hierarchical clustering. So here what happens? So you can calculate the distance between the two clusters, between every pair of data points using the chosen matrix. Okay, so if you're having two clusters, for example this and this, where you can calculate the distance according to the Euclidean distance formula. This is one approach. Anybody please tell me what is Euclidean distance formula? Assuming that this point is x1, comma y1, and this is x2 comma y2. Umair said square root of x2 minus x1 to the power, okay, whole square plus y2 minus y. Yes, correct. Very nice. Correct. Okay, then we have merge the two dataset closest cluster to form a new cluster. Yes. So if you found that suppose there was another cluster but it was very far away. Okay. So this is far away. So you will make a cluster of only this one. If you found out that these are nearer after calculating the Euclidean distance. Update the distance between these new clusters and all other clusters. Okay. So now what you will do, these 2 points, this the combination of these two clusters will be having a common point. Suppose you can say centroid. This will be the distance from. Now it will be calculated between this point and other. So this is centroid. Okay, update the distance between the new clusters and all other clusters. And suppose now this you found that this is forming a cluster because this is very nearer point, then you can make this one as a cluster like this. Okay, repeat step 2 and 3 until only one cluster remains or until a certain number of cluster is reached. So yeah, keep on making until the every data point is clustered. This is the agglomerative approach. Linkage criteria. Okay, between one cluster like this and another clusters, what is the linkage criteria? So single linkage means the distance between two clusters is the minimum distance between any single point in one cluster and at any single point in the other. So yeah, you can take any random cluster and you can join it like this. This is called single clustering, single linkage. Okay, second is complete linkage. The distance uh, If you go down, you can see the diagram is also made here. Complete linkage. The distance between two clusters. The distance between two clusters is the maximum distance between any single point in one cluster and any single point in another. So you see, these things are because see, one cluster is having a lot of data, right? So which data points we have to consider while linking the two clusters. So this is a theory about that. Okay. Some people take only one data points and one data point from the another cluster, then they link it and they assume that both are linked. Both clusters are linked. Sometimes some says that take any random points. The distance between two clusters is the maximum distance. Some says that the distance between both the clusters data points would be maximum. That is complete. Some says that let's take the average. The distance between two clusters is the average distance between all points in one cluster and all points in the other. Like जैसे for example एक क्लस्टर यहाँ है, एक क्लस्टर यहाँ है और एक क्लस्टर इधर है. इसमें जितने डेटा पॉइंट थे वो सारे इस डेटा पॉइंट से लिंक कराए गए. कुछ भी एवरेज आया होगा जैसे फॉर एग्जांपल 35 और हेयर ऑल्सो हर डेटा पॉइंट से यहाँ पे क्लस्टर करवाया गया एंड यू गॉट टू नो इट इज 65. ओके, तो दिस इज एवरेज, मतलब सब डिस्टेंस का काउंट लाइक 10, 11, 9 अपॉन नंबर ऑफ क्लस्टर्स. तो एवरेज करके 35 आए, यहाँ 65 आया, तो इट विल टेक 35 बिकॉज दिस इज द मिनिमम. इन दोनों की क्लस्टरिंग हो जाए. ओके, वर्ड्स लिंकेज. The distance between two clusters is based on the increase in the within total within cluster variance. इसमें ऐसा होता है कि फॉर एग्जांपल बहुत सारे डेटा पॉइंट्स है एक क्लस्टर में. Combining clusters where increase in within cluster variance is to the smallest degree. बेसिकली ये थोड़ा सा समझना मुश्किल है. तो व्हाट दे डू कि they find out the clusters distance, the data point distance. जैसे फॉर एग्जांपल यहाँ यहाँ का मैच हो गया, राइट? तो यू कैन से दिस विल मेक अ क्लस्टर. या नाउ व्हाट विल हैपन, अब हमारे पास दिस इज नाउ लेफ्ट. ठीक है, तो इसके लिए कौन सा डिस्टेंस होगा? इसके लिए ये वाला डिस्टेंस होगा या ये वाला होगा? बेसिकली इन दोनों में से कोई भी नहीं होगा. वी अज्यूम दैट दीज टू क्लस्टर आर नाउ लिंक टुगेदर. तो इनके जो बीच का जो पॉइंट होगा यहाँ पे, दैट विल बी द वी कैन से द सेंट्रॉइड. तो इस क्लस्टर को, जो कि अभी क्लस्टर नहीं हुआ है, तो इसको इससे लिंक करना पड़ेगा. right? If it wants to make a cluster with these both, so this centroid, so यहाँ पे minimum variance you can see, इस क्लस्टर और इस क्लस्टर के बीच में यहाँ पे मिनिमम वेरिएंस है, दैट्स व्हाई द वाट्स. So combining clusters where an increase in within cluster variance is to the smallest. Basically, it gives an impression कि like we are joining two clusters. तो उसके बीच का जो cluster होता है that will be now considered the centroid. So you have to connect this now. For example, suppose we have one cluster here, one cluster here. तो हर क्लस्टर के अंदर एक एक पॉइंट है. अभी फॉर एग्जांपल, तो इन द बिगिनिंग व्हाट विल हैपन कि पहले तो इन दोनों के बीच में क्लस्टर बनेगा, राइट? चलो बन गया क्लस्टर. अब ये बताओ कि इस पॉइंट के लिए जो कि यहाँ पे है हमारा ये वाला पॉइंट जो कि क्लस्टर नहीं हुआ है, इसके लिए कौन सा पॉइंट होगा? विल इट कनेक्ट टू दिस पॉइंट और विल इट कनेक्ट टू दिस पॉइंट? आंसर मी. नियर वन. नो नो, नियर नहीं नहीं, नियर वन नहीं होगा. वर्ड्स में यही तो प्रॉब्लम है. वर्ड्स में नियर वाला नहीं होगा, पर इन दोनों वी विल फाइंड या सेंट्रॉइड, करेक्ट. इसके बीच में एक सेंट्रॉइड फाइंड किया जाएगा. तो दिस सेंट्रॉइड विल बी नाउ द सेंट्रॉइड ऑफ दिस क्लस्टर. तो ये जो पॉइंट होगा इसके नजदीक से इससे क्लस्टर होगा, देन इट विल बी कॉल्ड एज क्लस्टर्ड. बेसिकली वर्ड लिंकेज क्लस्टरिंग का कोई देर इज नो एनिमेशन हेयर बाय द वे. ओके. The result how hierarchical clustering can be visualized using a dendrogram. So basically what is dendrogram? If you see dendrogram, it is just graph. This is called dendrogram, this thing. this one. This diagram is called dendrogram, which shows the hierarchy of merges or splits. The vertical axis represents the distance. Suppose if we have something like this, so vertical, so it is made in the axis. So vertical will tell us the distance between the or dissimilarity between the clusters. So it is for distance, and the horizontal axis shows the data point. So this is for data points. फॉर एग्जाम्पल जैसे यहाँ से इधर से लेके इधर तक एंड दिस वन. इफ यू विल सी, यहाँ पे फॉर एग्जाम्पल डिस्टेंस 2 है और यहाँ पे है 1, यहाँ 0.5. तो इफ यू सी 0.5, तो वी कैन से कि इन दोनों क्लस्टर के बीच में जो डिस्टेंस था दैट इज 1, बट यहाँ पे आ रहा है हमारा 2. ओके, लेट्स अज्यूम 0, दिस वन 0. यहाँ पे आ रहा है 2, सो वी कैन से दैट इनके बीच में जो डिस्टेंस था दैट वाज 2, राइट. So this vertical line tell us the distance. You can see over here. So it's like a graph only. Here on the y-axis it is distance. Wait, I think picture is not very clear. See, ये यूएसए के जितने स्टेट्स हैं उसका क्लस्टर्स है. तो जो जो पास हैं उसके क्लस्टर्स यहाँ पे हो रखा है. तो इस ब्लू वाले में जस्ट सी एंड टेल मी कि सबसे कम डिस्टेंस किस. ओके, इन दिस ब्लू वन ओनली टेल मी कि सबसे डिस्टेंस कम किसका है. इसका, इसका, या इसका, या इसका. रीड केयरफुली. इलाइनस एंड न्यूयॉर्क. नहीं नहीं नहीं, आपको इसमें बताना है रेड वाले में. सॉरी, सिर्फ ब्लू वाले में, यहाँ से लेके यहाँ तक जो है. दिस वन ओनली, दिस वन ब्लू वन में. इधर मत जाओ अभी आप. Alabama and Louisiana. Okay, this one. And Mississippi, South Carolina. Yes, correct. Right. So these two clusters is first. उसके बाद then we have Georgia and Tennessee. सबसे बाद में आता है the cluster of Carolina, North North Carolina, and the cluster of these two states because it is very heighted here. Okay. So this is how we see the distance. Okay. So distance or dissimilarity between clusters, the horizontals. Yeah. The height at which two clusters are joined represent the distance between those clusters. Okay. Now let's see the code. So import numpy is matplotlib, and from scipy cluster hierarchy, import dendrogram linkage, and from datasets make blobs. So basically, we don't have any datasets for this. We will make our own. So what we'll do, make blob and samples. तो 50 data points के साथ I'm making three clusters. I'm making. बाद में we will do linkage. Right now I'm making three. So this is raw data. I'm generating this data. Okay. तो cluster का standard deviation will be 0.6. Random state is 0. So let me show you कि how does it look like. पहले मैं I will not create the direct graph. सबसे पहले हम क्या करेंगे कि I will show you the x and y, कि x कैसे दिखता है और y कैसे दिखता है. See, यहाँ पे x एक्सिस और y एक्सिस आ चुकी है. ये सिर्फ x के अंदर है, ठीक है. अब y के अंदर क्या होगा, आई विल शो यू. ये सारे पॉइंट्स है, 50 पॉइंट्स हैं, पर इसमें कौन से क्लस्टर जैसे मान लो 3 क्लस्टर्स का डेटा है इसमें, ठीक है. और कौन सा क्लस्टर 0 है, कौन सा 1 है, कौन सा 2 है, वो इन्फॉर्मेशन यहाँ नहीं है. दैट इन्फॉर्मेशन इज इन द y. नाउ लेट मी शो यू द y. सी, पहला डेटा पॉइंट जो दिखा दैट इज 0 बिलोंग्स टू 0 1 0 0 2 लाइक दिस. तो व्हाट आई विल डू कि मैं देखना चाहता हूँ कि हाउ डज इट, कैसा दिखता है, और क्लस्टर्स कैसे दिखते हैं। आई विल स्कैटर प्लॉट। तो एक्स का जो फर्स्ट फीचर था आई विल सेलेक्ट इट एज एक्स। एक्स का ही जो दूसरा फीचर था वो वाई के अंदर पुट किया स्कैटर प्लॉट में। और कलर में उठाऊंगा हमारे वाई डेटा सेट से। तो तीन कलर मिलेंगे क्योंकि तीन तीन टाइप के क्लस्टर्स बनने हैं। तो तीन टाइप का डेटा उठेगा और कलर, और तीन कलर आ जाएंगे यहाँ पे। तो लेट्स क्रिएट इट। सी, यू कैन इजीली सी थ्री क्लस्टर्स यहाँ पे बन गए हैं। ठीक है। अब एक चीज़ और दिखाना चाहता हूँ। अगर आपने फॉर एग्जांपल यहाँ पे फाइव क्लस्टर्स लिए होते हैं, डेटा पॉइंट अगर फाइव क्लस्टर के हिसाब से बनाया होता, तो यहाँ पे फाइव क्लस्टर्स बनते हैं। ठीक है। और अगर आपने यहाँ पे स्टैंडर्ड डिविएशन बहुत कम रखी होती, सी डेटा इज नॉट मच स्कैटर्ड, काफ़ी पास पास है। तो मैं नॉर्मल करता हूँ अभी। और राइट, परफॉर्म hierarchical clustering using the word method. So let's do the linkage now. So linkage, call the linkage function. Pass your data points, 50 data points. तो मेथड कौन सा लोगे आप? वर्ड ले सकते हो मेथड। कितने सारे मेथड है हमारे पास? बहुत सारे मेथड है। सिंगल, कंप्लीट, एवरेज, सेंट्रॉइड, वार्ड। करके हमने बनाया जेड। आफ्टर लिंकिंग जेड विल बी क्रिएटेड। इफ यू वांट टू सी द जेड, अब हर डेटा के लिए यहाँ फोर फोर पॉइंट्स आ रहे हैं। तो लिंकेज इज डन। तो पीएचडी डॉट फिगर वी हैव क्रिएटेड आवर कैनवस। तो डेंडोग्राम के अंदर हमने अपना डेटा पास किया, तो इट विल क्रिएट डेंडोग्राम। एंड टाइटल वी हैव गिवन एक्स लेबल, वाई लेबल। ओके, लेट्स ट्राई टू रन इट। सी दिस, डेटा पॉइंट्स इतने सारे थे हमारे पास, उनके डिस्टेंस जिसके पास पास थे दैट कन्वर्टेड इनटू वन क्लस्टर, देन ग्रीन वन। Total 50 data points are there. You can count. See, it created a dendrogram. Very nice. So what if we try to create using the So with the help of centroid, it is also making a similar kind of thing. So single linkage, so how many types of data method we have? Methods, single, complete, average, centroid, median, weighted, ऐसे ही बहुत सारे हैं. So you can try any complete, average. Is this agglomerative clustering? नीचे से ऊपर जो बन रहा है ना ये, तो बॉटम टू टॉप वाला कौन सा था? Bottom up is agglomerative, yes. This is agglomerative. Okay, student, do one thing. Can you try this thing in your iris data set? Please try to do it. सारे फीचर्स एक्स में करो और जो भी हमारा टारगेट डेटा है वाई में करो. Try to make a linkage and revisualize it in the dendrogram. So make this code and show me. Data points on X are cluttered, but try to rotate it. Rotate it means you can rotate the X label by writing this. Pt.x6 rotate 45 degree like this. It rotated about 90 degree. Yeah, try to rotate something so that we can see or make your graph little bit bigger. Yes, like rotate like this. Okay, very nice. So when to use hierarchical clustering? So when small data sets. So hierarchical clustering is computationally expensive on n cube. So it's best suited for the small or medium size data. Yeah, try to take medium size data. Need for hierarchical structure is it is useful when you want to visualize the hierarchy of clusters or when there is no predefined number of clusters. Yes, so there is no cluster. You don't know how many clusters are there, so you can use this like for finding the virus. Non-spherical clusters. So hierarchical cluster can find more complex clusters such as non-spherical. Yeah, for spherical K means is fine, but for For non-spherical, you can use this. Advantage is no need to pre-specify the number of clusters, like K means. Produce a hierarchy of clusters which can be useful for understanding relationship between data points. Work on non-spherical cluster. Disadvantage of hierarchical clustering is computationally expensive, especially for large data set. It takes a lot of time. Sensitive to noise and outliers. You cannot add the outlier, so better remove it before it. Once a merge or split decision is made, it cannot be undone. Greedy algorithm is followed. So yeah, these are summary, like this is a unsupervised technique used for build a hierarchy of clusters. The agglomerative approach is more common, starting with the individual data points and merging them into large clusters. It is visualized using a dendrogram, which have been understanding the cluster at the different level. Okay, so tomorrow we'll do our last topic of the data science. Okay, so try to use this hierarchical in any data set which you find from the Kaggle, and this is your homework. Please show it to me tomorrow. Okay, have a good day. Bye bye. See you tomorrow.